name is Carol Wynn Whiteman, and today we'll be exploring geometric patterns using geometric shapes. Now, patterns are all around us. Sometimes you see them on the carpet in your floor, you see them on your bed sheets, the prints on your shirts. Patterns are all around. But today we are going to specifically look at patterns using geometry. Now, if you look at the table, I have set up two sets of patterns. One involves patterns of color. It's repeated. So we have yellow, blue, red, and green. We call that one unit or a core. So the pattern that's repeated is called the core. That's the one that's repeated. So if you look closely, you will see yellow, blue, red, green, repeated yellow, blue, red, and green, and repeated yellow, blue, red, and green. So we have a repeated pattern of colors. The second one shows us repeated patterns of geometric shapes. So here we have a rhombus, a hexagon, a rhombus, two hexagons, a rhombus, a hexagon, a rhombus, two hexagons, a rhombus, one hexagon, a rhombus, two hexagons. Can you determine what is the core from this? Yes, you are correct. If you stated a rhombus, a hexagon, a rhombus, two hexagons, that makes the core, because that is the repeated pattern that we have used. But patterns can also be repeated in numbers. For example, I can have 1, 2, 1, 2, 1, 2, 1, 2, and that is a repeated pattern. I can also have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Again, that is a repeated pattern. So let's summarize what we have done so far. A pattern is formed by repetition. We can repeat colors, we can repeat shapes, or we can repeat numbers. The unit that we repeat is called the core. So the first thing we are looking for is the core, and we're going to look to see if it's being repeated. We are using a repeating pattern to solve this problem. Read along with me as I read the problem. Marcy is using the shapes below to make a border. If the pattern continues to the 38 shape, how many right-angled triangles would she use? Let's go again. Marcy is using the shapes below to make a border. If the pattern continues to the 38 shape, how many right-angled triangles would she use? What do we need to know? We need to know, first and foremost, the 38 shape. We also know that we have to find out how many right-angled triangles. So we must know what is a right-angled triangle. So let's show the right-angled triangle. We know a right-angled triangle is formed when two of its sides are perpendicular. So a right-angled triangle, again, two sides form 90 degrees, or they are perpendicular. What else must we know? We must know if this is a repeating pattern, then there must be a core. So let's identify the core. Remember, the core is the unit that is repeated. So what do we have? There is a rectangle, a triangle, 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 a triangle, a rectangle, a rectangle, a triangle, a triangle, a triangle, a triangle, and a rectangle. Clearly, the core for this pattern is a rectangle, a triangle, another triangle, third triangle, and triangle and a rectangle. This is the core that is being repeated. Now, let's go to the problem. If the pattern continues to the 38 shape, how many shapes do we need to make our core? 1, 2, 3, 4, 5, 6. So there are 6 shapes to make the core. So if we need the 38 shape, how many would we need? 38 divided by 6. 6 into 38, 6, remainder 2. So we need 6 of the cores to make 36. And there will be 2 extra shapes. Let's go. 1 core, 2, 3, and we will need to get 3 more. So that will give us 36. And the extra 2 will be the start of the 7th core. 1, 2. But that's not all. The question asks, how many right-angled triangles? So let's find out how many right-angled triangles there are in each core. 1, 2, 3, 4. So in one core, there are 4 right-angled triangles. Therefore, since we need 6 to complete our pattern, 6 cores, there are 6 times 4 right-angled triangles. That will give us 24 triangles. But that will only take us up to the 36th step. So we need 2 more. 1, 2. So this right-angled triangle must be counted. Therefore, for the 38th step, there will be 24 plus 1 right-angled triangles, which gives us 25 triangles. Remember that it is not only 6 cores we need the 38th step. So therefore, we need the extra 2 to complete the 38th step. 6 cores will only give us 36 steps, so we need to start the 7th one, 37, 38. And that is why we are adding this extra right-angled triangle to our 24. So to answer the question, if the pattern continues to the 38th shape, how many right-angled triangles would she use? Our answer, 25 right-angled triangles. So far we have done repeating patterns. Let's just go over what repeating patterns are. A repeating pattern is made up of a unit called a core. It may be numbers, where the numbers are repeated. So in this case, the numbers 1 and 2 make up the core. Or it could be colors. For example, I can have blue, then green, then white. That's my core, and I can continue again with blue and green and white, and I can repeat that. Or I can have shapes. For example, I can have a circle, a triangle, a rectangle, and a parallelogram, a circle, a triangle, a rectangle, and a parallelogram. And I can continue a circle, and one would know that the next element would be a triangle, and so on. But there's another type of pattern called a growing pattern. In this case, the element increases as the pattern increases. Something is added onto each element as the pattern increases. Let's have a look at the growing pattern on the desk. The first one is made up of a hexagon. And onto that hexagon, we have added a second hexagon. And then we have added a third. So you will see that the pattern is growing. I want us now to look at the pattern given and see if we can determine how many matchsticks will be needed to make the sixth shape. The first shape, 1 hexagon. The second shape, 2 hexagons. The third shape, 3 hexagons. The fourth shape, 4 hexagons. So you can see that our pattern is growing. Therefore, you will be able to determine how many hexagons will be needed for the fifth shape. And just like that, the sixth shape. Okay, so if the first shape has 1 hexagon and the second one has 2 hexagons, the third has 3, and the fourth has 4, we can infer that the fifth will have 5 hexagons and the sixth, 6 hexagons. Let's put that on the board. The sixth shape. So we are drawing 1 hexagon, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This will be our sixth shape. Now let's count how many matchsticks we use to make the sixth shape. Starting here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So we use 31 matchsticks to make the sixth hexagon. But as usual, we are looking for a pattern. So let's put down in a tabular format the number of matchsticks we use for each step. So, shape, number of matchsticks. And this is very simple. You can do this at home. The first shape, we used 1, 2, 3, 4, 5, 6 because it was a hexagon. The second shape, let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and don't forget the one in the center, 11. The third shape, let's go again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Are you observing anything as yet? Let's continue. The fourth shape. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we use 21. Take a few moments, have a good look, and tell me, without drawing the shapes, how many matchsticks do you think will be needed for the fifth shape? Do you notice anything? Any pattern? Yes, we are increasing by 5. 6 plus 5 will give us 11. 11 plus 5 will be 16. 16 plus 5 is 21. So 21 plus 5, we will infer that the fifth shape will take 26. And therefore, for the sixth shape, we are going to add 5 to 26, and we should get 31. 26 and 5 is 31. Therefore, if I should challenge you as to how many matchsticks I will need for the ninth shape, let's go. We will set up our table. Shape, number of matchsticks. So if our sixth shape use 31, our seventh shape, we're going to add 5, which will make it 36. Our eighth shape, we're going to add 5 because that was the pattern that we found out. 36 and 5 will be 41. So our ninth shape will be 41 and 5, which will be 46 matchsticks. Of course, you also have the option of drawing the ninth pattern. Let's take a look at the question. A pattern is formed using dots on the sides of pentagons as shown below. Study the pattern and state how many dots will be needed for the fifth figure. So again, a pattern is formed using dots on the sides of the pentagons shown below. Study the pattern and state how many dots will be needed for the fifth figure. So let's see. On the first figure, let's see what pattern we can get. The first figure has 1 dot in the center. The second figure has 2 dots in the center. And the third figure has 3 dots. Therefore, we can infer that the fifth figure will have 5 dots. Let's draw our pentagon to see. So 1, 2, 3, 4, 5. And following the pattern, we are going to place 5 dots on each side. 1, 2, 3, 4, 5. Just how this one has 1 in the center, we will put 5 in the center. So 4, 5. On this side, we have 1 dot, so we are going to put 5 in the center. 1, 2, 3, 4, 5. And again, 1, so we are going to put 5 in the center. 1, 2, 3, 4, 5, and the 1 at the top. And similarly, 1, 2, 3, 4, 5, 1 at the top, and 1, 2, 3, 4, 5. So let's count how many dots we have placed on this pentagon. Starting here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So the fifth pentagon will have 30 dots. But let's see if we can do this another way. If you observe carefully, the first pentagon has, let's count the dots on the first pentagon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's count the dots on the second pentagon, starting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm sure you can see where I'm going here. On the third pentagon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So let's make a table to represent this information. So we're going to put the figure and the number of dots. So the first figure used 10 dots, the second figure used 15 dots, and the third figure used 20 dots. What can you observe? Yes, on this side we have multiples of 5. So we can assume that the fourth figure will be 10 and 5, 15, 15 and 5, 20, 20 and 5, 25. So the fifth figure should be 10, 15, 20, 25, 30 dots. Again, the first figure, 10 dots. The second figure, 15. The third, 20. The fourth, 25. And the fifth, 30 dots. So there are two ways that you can do this problem and solve the problem. We can either draw the figure and put in the dots, or we can use our table. And this concludes our session on geometric patterns. I do hope that you have learned about growing patterns and repeating patterns. Look around you. You will find them all over. So I challenge you to look with your friends for the different patterns, and good luck. Goodbye.